Hi, my name is Daniel Norstrand, and I'm doing the 5 concepts related to data mining. The first concept that I'm doing is data cleansing. With data cleansing, you format the data to be able to be imported cleanly without any mistakes or overlaps or errors, and so that the import can be done smoothly. You can also handle null values or missing values, either through completely removing the record that contains a null or missing value, or by populating it with an averaged value. What I have here is just a small Python script that I have that I can run through a CSV file and clean it up so that it's easier to import and a lot cleaner. And inside of SAS, after being imported, I edited the variables and selected my target, as well as made sure that the level was correct on each of the different input. The second concept that I'm going to talk about is data partitioning. With data partitioning, you want to make sure that you have a large enough data set for the learning, but you want to also make sure that you're not overfitting the data or overfitting the model to the learned data, which makes it not a very good fit for actual use. So with the data partitioning, I set to 70% for training, 20% for validation, and then 10% for testing. The third concept that I'm going to speak about is splitting rules, and this is, at least in my presentation, is specific to the decision trees. So with decision trees, as the professor said in the lecture, you have to have some sort of a way to tell the machine how to split the data up. We had the model in class where you could just look at it and there were only 2 or 3 nodes to choose from, a couple ways to split the data. But when you've got several models, you've got to have some sort of way of logically being able to split each node as you're breaking it down. And with SAS, they actually have a few different formulas built in. There's the probability, I'm not even going to try to pronounce that because I know I'm not going to get that right. There's entropy and a Gini, it looks like. So I can run with each one of these and try to see which one fits my data the best. The fourth concept that I'm going to talk about is pruning. As the professor had said, that if you can continually split down the data down almost to the ridiculous to each individual decision, but the decision tree at that point would be overfitted to your data set. So you don't want to do that. So you want to be able to prune, or in the case of the the SAS tool, you kind of do it proactively. You tell it the maximum depth, the number of surrogate rules, the leaf size, in order to prevent the data from being broken down too much and the rules being overfitted to your data set. The fifth concept that I'm going to talk about is regarding learning the structure, and that's with the neural networks. With the neural networks, the professor had talked about doing like you know your inputs, you know the output that you're looking for, but you kind of have to play around with or experiment or try to learn the hidden nodes. How many hidden nodes will best work for your data set. So in SAS, you can set the number of hidden nodes under train and network. So the default is 3. So you can increase that or decrease that to between integers of 1 and 64 to try to play around with and determine what what value best works with your set. Like the professor said, that at least at this point it's more of an art because we don't have it down to a science yet. That is my demonstration and the 5 concepts for data mining. Again, my name is Daniel Norstrand, and thank you very much.